Hello. Test. There we go. That looks better. Cool. Hello. Hello. Let me pan up a little bit so you can get my. Let me pan back down a little bit. My hair is not looking great right now. I need to figure something out with my hair. Oh, hello. And we've got ourselves a Nelly. Cool. Long time no stream. Not actually a long time. I streamed on Friday, although at a weird hour, and it wasn't a usual stream. But still. So, what are we doing today? I want to, first of all, catch you up on some work I did. On Thursday, I did work to get lasers going. For a laser power up that you can get to help you destroy bricks in the brick breaking game that we're making. So we did some work on that, and after the stream, I had a thought, and I followed through on that thought, and I just want to show you what it was. Let's ignore that. Oh wow, whoops, that is not what I wanted to do. And it's screwed up my terminal. Oh, hi Nelly. Yes. Lasers. Yeah, here we go. So previously, what I'd been doing is in the update lasers, we were moving the laser, and we were checking to see if the laser went out of bounds, and if it had, we were marking the laser as inactive. You can see all of this here in update lasers. And that required some like stack operations in order to preserve registers, and it was just kind of wasn't super happy with it. It was a little overly complicated. I got thinking about it, and I think the big differences between programming a game in assembly language on the Game Boy versus good programming practice, I guess, is for me, anyways, for my personal, and I suspect that there's maybe other Game Boy programmers who feel differently about this, but I think it's important to keep any individual process as simple as possible, even at risk of possible performance degradation, possible what's the term I'm looking for? Like adding more processes in such a way that I'm having a hard time articulating this. Bear with me. When you're doing normal programming, I would say it's really important at any time to, as much as possible, preserve a consistent state for the world, so to speak. So that's sort of the invariant that we're preserving here in Update Lasers. The idea in Update Lasers is that whenever a laser moves off screen, it is immediately marked as inactive. The state of the world is consistent. You for a very short period of time, certainly never leaving the span of Update Lasers or even one iteration of the loop through Update Lasers. Any laser which is off screen is marked as inactive. And this is a good practice to think about these kinds of invariants because it helps you reason about your program. The unfortunate reality, that's for doing real programming. The unfortunate reality is on the Game Boy, there are reasons why doing that isn't necessarily a good idea. Because it means that you need to have these, like, in this case, like a fairly complicated update lasers routine, which is kind of hard to reason about. It means you have to do these stack operations, which are slow and kind of ugly. They're bug prone in case you accidentally screw up the order in which you push and pop things off the stack. You generally kind of want to avoid stack operations. Um, there's like a risk of the sort of stack operations that you need to do for clear laser falling out of sync with the stack operations that you do in update lasers before and after calling it. It meant that there's like different. We had to approach the loop in a slightly different way. Like traditionally on the Game Boy, when you're doing a loop, you want to take advantage of the fact that a decrement instruction automatically sets the 0 flag, so countdown loops are faster than count up loops. But the way I was doing this here, I needed to write this as a count up loop so I could keep track of which laser I was on, and which laser was being updated, so I could send that over to clear laser to mark it. So in this case, trying to preserve that invariant made the code a lot more complicated. And I wasn't really happy with it. So I rewrote this slightly. So instead of doing that, update lasers is just going to move all the lasers, and then after that, it's going to go check to see which lasers have gone out of bounds and mark those as inactive. So that means that I've split up this one kind of complicated loop into two smaller loops. One loop to move the lasers, one loop to mark them as inactive. That's probably a little bit slower, but each loop ends up being quite a bit simpler. It's now a countdown loop. They're both now countdown loops. The move loop in particular is very simple. We just check to see if it's active. If it is, then we do the move. That's it. Yes. You still need to do this thing where you've got the mask to determine which lasers are active, but that's no big deal. And then the clear and active lasers loop. This is really nice because then we can also build the new mask in place instead of trying to modify the old one. So that becomes a lot faster because you don't need to do the unpleasant loop that we were doing inside of clear laser, where we have to go shift through to mark the right thing in the mask. So this if you're really curious about the implementation, of course, I'm not going to walk through it line by line. The code is up or will be up on GitHub whenever I get around to pushing it. You can read it there. I don't think that is as interesting as this sort of general principle of preferring smaller, simpler loops, even at the cost of consistency throughout in invariance within the loop. I think this is like a good strategy to take when you're on the Game Boy, or like sometimes you're doing things. I do this with the OAM routines as well. Let me just pull those up really, really quickly so you can see what I'm talking about here. That's in lasers as well, actually. I think. Maybe it's not. Maybe it should be. Oh yeah, here we go. Setup lasers OAM. Instead of iterating through the lasers once and setting up the OAM slot for laser 1, laser 2, laser 3, laser 4, I iterate through the lasers 3 different times. I do it once for the Ys, once for the X's, and once for the tiles. And this just makes things simpler because I only need to keep track of, in this case, the issue is I only need to keep track of my position in one array, in the lasers, laser Y's array, the laser X's array. And then this loop is very, very simple because I'm just writing a constant in every 4 slots. So I do think this is a really good strategy to bear in mind when Game Boy programming, is to use more simple arrays, even if it means that, like, in between these calls, the state of OAM is like kind of in a weird incomplete state. And if I were programming this in C, in a high-level language on a CPU, which is more sophisticated, I would instead prefer to just have one loop And so I'd be able to say at the end of each iteration of the loop, okay, now the OAM for this laser is done. Like that's easier to reason about. There's this invariant, but um, because of the way the Game Boy is, it can be better to use multiple loops, even if it leaves things in an inconsistent state for longer. So, anyways, that's my sort of rant and what I wanted to talk about with regards to that work I did after last stream. Beyond that, um, I did start to work on collision detection. I wanted to get more collision detection work done, but I didn't have time. Whatever, busy. So, yes, Nelly. Yeah. Nelly takes up a lot of my time. So I did start working on some collision detection changes, and the big thing there is that let me do a git diff to show you. None of this is committed yet, so it's just in progress. Nelly, come on up. We're going up. Woo! There we go. We got a cat. Pew pew. Laser cat. Oh baby. So the big thing is that the collision detection was written in a way which is very much like the thing that causes the bricks to break is the ball. And the collision handler for the ball, the collision handler for the brick would be responsible for bouncing the ball off of it. And it would do things like it would use the position of the ball to determine which brick to break and stuff like that. Now, obviously, we for the lasers, we can't do that. The bricks that we break are determined by the laser that hits them. The laser that gets destroyed is determined by the laser that hits them. We don't want to bounce the ball when a laser hits the brick. So the collision detection code needs some rethinking. And the basic idea is that we're going to use the the object is going to be responsible for checking collision against, like checking to see if a particular location has a brick in it. And if it does, the collision handler will be run. And the collision handler will do things like destroy the brick that was hit. And then it will set a flag which indicates that a collision happened. And then the original routine that called the collision check, the update laser, the update ball, or whatever, is then going to be responsible for bouncing the ball or destroying the laser or whatever. So that's where things, that's what I'm working on today. It will not be a long stream, probably. I've been talking for about 15 minutes now. I'm probably going to be about 45 minutes of coding in. I don't know how much talking I'm going to do while coding. I think I'm mostly going to be kind of like focused on the coding rather than trying to explain every little thing I do, although we'll see. Yeah, that's the idea. That's half done now, but I'm still missing quite a bit. So let's get to it. So I'm actually going to build and I think I got it to the point where I get lots and lots of errors, which is what I want. So I want a flag which I'm going to call collided. I want variables which are going to be called hit brick call and hit brick row. I think that's all I want variable wise. And I don't know what collision tile is used for. I do know I want these to be public. Okay. Yeah. And then I need this routine called check for collision, which is what I think some of these should probably move to the ball code for consistency, but whatever. And the naming is getting a little sloppy, for which I apologize. What did I even just call? Oh, gnarly. I worry about you so much. I think I called it hit brick row. Call. So the collision flag is set, and the is run. Collided flag. So we just clear that out, so that and then we only set it if we need to. Like stage map. Oh my gosh. Start with hit row. Each row so each row corresponds to each row on the stage map corresponds to two. I'm trying to think of the words to describe this. So the stage map is arranged as 8x8 tiles, but an 8x8 tile actually contains 2 rows. So yeah, I hope that's clear. I don't know if it's clear. So we're going to shift right logical A. Let me put that actually off to the side. But then I might actually get to simplify this a little bit, because then we have to multiply by, each row corresponds to, I believe, 8 tiles. So we actually will then multiply by 8. So that would be, that multiplies by 2, that multiplies by 4, that multiplies by 8. To get the offset into the thing. So yeah, that's fine. And then we're going to and then we're going to load that into L, and then we're going to get the hit brick call. Okay. Oop. We're going to hit brick call. We're going to. I'm actually really relieved that I'm making this change, because this stuff I really hated. So the less of it I need to do, the better. And there's like some similar nasty stuff over in game.asm. I definitely can clean this up a little bit. Load A, hit brick call. We're going to add that to L. We're going to load A. There we go. Now we've got our pointer into the stage map data for the correct tile. We're going to get that tile. And now we have to, so get tile. Now we have to, from there, if we care about the top or bottom brick in the tile. So here we just get hit brick row again. And this is easy. Basically if it's an odd number, then we want the bottom. If you think about it, the top tile is 0, or the top brick is row 0. The second from the top brick is row 1, and so on. If it's an odd numbered tile, we want the bottom. If it's an even numbered tile, we want the top. Easiest way to test that is to roll into carry. That'll just put the bottom bit into the carry bit. And into the carry flag, and then we can use the carry flag to determine which half of it we read. So now I just need to remember, how do I arrange the bottom and top? I think the bottom is just, yeah, okay, the bottom is the bottom bits. So useless comment. So in the top, what we're going to do is we're going to, actually I can probably do it like, call it here. All I'm going to do is and out the bottom, or sorry, and out the top. No, all I'm going to do is swap. That's what I'm going to do here. That's the fastest way to do it. So that's if this means that we care about the bottom, so we're just going to check the tile. If we care about the top, we're going to swap the top 4 bits and the bottom 4 bits so that the top is where the bottom is, basically. And then we can clear out the bottom, and then we can work our magic. Our magic is to okay. What do I do here? Collision handlers, do nothing. Do I run it every time? Okay, so I run it every time, which is all I'm going to do here is ret 0. If the bottom brick is empty, do nothing. Right, so this clear is good. If the bottom brick is 0, this is going to equal 0. It's going to set the 0 flag. We're going to do nothing. We've cleared collided out. Otherwise, we're going to use this to look up. We're going to use this to look up a collision handler. We have to double it because each collision handler is, because we're now treating the tile number as an index into these collision handlers, and each entry is 2 bytes because it's a 16-bit pointer. We add that to the base in L. We load LA, L with A. Then we're gonna get the pointer into HL. And before we run the handler, we are going to set the collided flag. And then we are going to jump to the handler. So, not too bad. This is pretty good. What's nice is I can now get rid of this. I can now get rid of this. I can now get rid of this and this. I don't have. I still need this actually. It's easier to just keep that, so I don't need to do any math. It does cost me 2 bytes, but whatever. I'm pretty sure I can get rid of get collision tile. Although I might want to keep this a little bit. I might want to keep the collision tile variable, possibly, but I can get rid of, we'll see, I might not actually. I can get rid of the routine anyways. So let's build that. Check for collision. That should now be public. So I can call it from laser. Okay, good start, good start. So now the other thing I need to do is I need to rewrite these over in game.asm. These were using the position of the ball to determine which brick to destroy, and I don't want to do that. I want to now use hit brick call and hit brick row to do that. So we're going to have to do this sort of thing again, but that's no big deal. It's fast enough. Get rid of get ball map address, get tile at ball. Probably want to get rid of this as well. This is now going to be called replace brick. Yeah, I think I'm just going to rewrite these. That's the sad reality of it. Place brick on stage map I might be able to keep. I don't know. No, not really. I'm going to have to rewrite an awful lot here. It's unfortunate, but yeah, a lot of this. I'm tempted to just delete all of this because so much is going to need to change. Yeesh. It's really unfortunate. So what are we doing here? We are going to and I'm going to have to do similar stuff over in Flash as well. This is the other place where things need to change. Yeah, it's also based on this idea that we're using the ball. My memorize up. So let me start here because this is probably easier than anything. So we're going to start with load A, hit brick row, and yeah, this is So this we're gonna get the y here, and this is easy. We just multiply it by 4, and then add. I believe it is stage ISM to the side. We start drawing at 9842. So yeah, it's two down. So we just add. All we're gonna do is we're gonna multiply this by 4. It's easy. We just do that, and we add 16. And we're going to add 32 to account for the fact that it's a sprite, and sprites have a negative 16 y offset. And we're going to load that into flash brick x, or sorry, flash brick y. Yeah, that's nice and easy. This one is nice and easy. Big fan of this one. Hit brick call. Similar idea, except we're multiplying by 8. And we have to then add 8 plus 16. And we're going to have to add 24 to the offset. And yeah, I should be using constants. If you haven't watched some of the previous streams, I'm kind of trying to just rush to get this out so I can move on with my life. So I acknowledge that things might get a little bit sloppier than I would like. But this is the basic idea for flashing a hit brick, and that is nice and easy. I'm very happy with that. What do I call flash brick? Should be called like flash hit brick. There we go. And then I have to go over into game.asm, and I need to fix that. The replacement code, which is much worse. And it's much worse because it involves two separate things. It involves updating the stage data, and it involves setting up a VRAM write to update the map data on screen. And both of those are pretty unpleasant. So, but I'm just going to rewrite it here and delete as much as I can. Honestly, I'll probably be able to restore a fair amount of this. So let me. I probably don't need to delete this. Maybe I've been overzealous about deleting stuff here, very possibly. Okay, replace hit brick. Okay, because what I'll do here is I just take the I need to check to see whether the ball row is based on 4 pixel rows or 8 pixel rows, and maybe adjust that. This should just stay the same, basically. I do need to check that. And all of this should actually stay the same, I think. So we have to compute the screen destination, which is unpleasant, but I think I can spare it myself. I'm safe from that. So what else do I need to do? I need to get the replacement tile. Which, did I delete that? I totally did. Let me. And, understandably so. Because it sucked. Where did I put that? That was replace brick on stage map. Sorry, it's above replace hit brick. Let me close that out. let me actually go in collide.asm. Yeah, this is called collision tile. I'm going to make that global. We're going to get it. And write it in. So that way, all we need to do here is we first get the collision tile. We're going to roll it right in order to shoot. Do I want RCA or RRA? I might want RRA instead of RCA in these places. Also, that syntax is wrong. Let me go back over to collide. Actually, let me open this up. Oof. Pull a new tab out over here. Yes, RCA. The carry becomes the value leave on the rings. Okay, that's fine. That's good. That's what I want. Cool. So let me go back over here. But then we have to load the collision tile again. Or actually, this is very sneaky. I don't need to do that. I don't need to reload it. Maybe it'd be better if I reload it. Because all I did was a rotate, which is non-destructive, so I could just undo the rotate. Although the problem then is preserving the status of the carry flag, and maybe it's just not worth it. Might not be worth it. Let me keep writing this. So what do we want to do? We want to, I think just based on the carry, I think it's just totally different. Like if it's the bottom, then what we want to do is, there's another thing, right? There's like over here in collide, I just need to refresh it here. Replacement brick. Right, we want to use the replacement brick. Oh, this is good. This is kind of annoying actually, because what we want to do is kind of oh, not necessarily. Okay, I can just OR it in. I can just OR it in and do the swap on both sides. Sorry, I'm thinking out loud and not explaining myself super clearly. So we're going to put the replacement brick into B. I'm just going to write this. So for we're doing the top, what we're going to do is we're going to swap B, which is going to put it in the top nibble of B, the replacement brick in the top nibble of B. Then we're going to aim out the top brick of A, the tile that's currently there. And I think that's all we want to do. And then here in bottom, oh, actually, yeah, no, we have to do it like this. This is a little annoying. It kind of sucks, but. And then in bottom, and then I want to jump this, call it right, I guess. And then in bottom, we want to clear out the top, or the bottom, so that we can just mask it in. And then we're going to have that right here. I don't think there's a nicer way to do this. All we do is we ore it in, and then we're going to write into replacement tile the new value. I think this will do what I want. It's nicer now because we don't need to worry about. Wait, is this isn't right? Right, we don't want to. There we go. Okay, I was using the wrong thing anyways. We care about hit brick row, not collision tile. So my feeling of trying to optimize it anymore was silly and unnecessary. So use hit brick row to set the carry flag to determine whether or not we're working with the top or bottom of the tile. We get the replacement brick loaded into B. We get the tile that we collided with. And then, depending on whether we care about the top or the bottom, we do some basic bit manipulation to get everything in a nice state. And then we just mask into the replacement brick and write it into the replacement tile. Easy. Don't need to get tile.ball anymore. How about replace brick on stage map? Okay. Yeah, here, I'm just gonna, I deleted that too, right? Get brick, get ball map address. I mean, that's basically, that's this here. I'm wondering if it's worth putting this into a separate procedure or just doing it again. I'm going to just do it again for now, I guess, because, yeah, I'm just going to do it again for now. I'm not going to put it into a separate procedure or anything like that. And then load a HL. Wait. Sorry. And then just load the replacement tile and write it in. That's easy. I think that's everything. I'm sure this is not going to work properly at all. I made a lot of changes. This is a big, ugly change. But it does build, so let's see how that goes. I'm quite sure this will be catastrophic, actually. Yep. Check stage collide. Oh yeah, that's why. I need to rewrite this check stage collide stuff. Call check stage collide. So maybe what I should do is I should instead make it the responsibility of the caller to clear collided. That's the problem. And I think that makes sort of a certain kind of like sense. Like it becomes very clear here that we expect this to modify collided. So I just need to go find, I believe the only other thing that calls this is in lasers. I need to go over here as well. I definitely call it somewhere else. Oh, check for collisions. That's where it is. That should do it. That should fix this first of what will undoubtedly be many bugs. Yeah. So something's definitely wrong here, as you can see. Unfortunately, none of them are triggering like an exception, so to speak. They're not writing to any broken memory or something, so it's hard for me to know what exactly is causing this collision detection issue. Let me go check to see this ball code. I'm a little curious. Ball row, which I believe yeah, this is based on 8x8. I want to see, do I use ball row anywhere besides for that collision detection? Because if not, yeah. So this is the problem, or a problem. One of many problems. I'm going to count for ball center, map start row. Right, we shift right 4 times. You divide it by 8. We actually want to divide it by 4. I want it to be a 4x4 ball row instead of the 8x8 ball row. It's very easy to get from the 8x8 to the 4x4, but you just multiply it out again. But using a consistent notion of row will make this a little easier, I think. I think this will fix it. Oh no. Oh, yeah, I've seen this happen occasionally. I don't know exactly what causes it. I've got some sort of issue there. Well, that is not better. There's some kind of collision detection happening, it seems, but like, who knows, really? I can't really make heads or tails of that. Let me shoot this off, pause it. Let's go find the ball row. What do you think our ball row is? You think we're at 10, row 10. So if I go into tile edge and look at my map, I believe this is it. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is a little off. No, actually, that's about right. Actually, yeah, that's right. And then what do I think the ball column is? Ball column is 6. 0, 1, 2, 3, 4, 5, 6. That actually looks basically correct. That which gives me reasonable confidence that I can debug this. Just starting from like check stage collide. Let's go into one of these check stage collides. So we clear the collided flag. We go into check stage collide. How does check ball and bounds do? That's a problem. This is based on the idea that we are 8x8 and not 16x16. So let me fix that. Because we are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. And one other place that we use ball row. Reload run. Okay, so we are getting some collision detection, but we're writing it to very bad places. But we are getting some kind of collision detection, which is another good step, and it seems to be bouncing okay. Right, so like all of this should go into the ball code instead, but I'll do that sort of cleanup later off stream. In fact, I'm going to leave a note to myself to do new ball code collision detection think I did this. Maybe I didn't. I'm not sure. I'll double check that later as well. Move ball could include injection into ball. So I feel like much of this might be okay. And the real problem now is in that stuff I was just doing over in game.asm. Yeah, well, it makes sense that if I was using ball row here previously, this is, the math here is wrong. So we want to find the screen row based on this. So we multiply this out by, so we actually want to shift it right, or clear out the bottom bit. So we want to shift that right to clear out the bottom bit. And then we want, or no, I don't want to just do that. And why I say that is, like, if we are in, for example, row 3 or sorry, row 4 or row 5, the screen row that corresponds to that is the same either way. And then what do we want to do? We want to multiply it, right? Actually, just for the sake of, I'll optimize it in a second. What we want to do basically is turn it into the 8 by 8 by doing that further division. And then we want to multiply it out by 8. So to multiply it by 8, we do that, and add a. So really, this is like 2 shifts to the left plus, and then we want to add 2. I don't know if it's worth trying to figure out. This is like pretty tightly optimized, and I'm not feeling smart enough to fix that right now. Let me see if this helps. It does not help. It does not help at all. Something is still wrong. So let me, in that case, go to setup, replace with transfer. I'm gonna hit run. Let's just step through this math, okay? So the brick we hit is supposedly in row 14. Does that check out? That probably checks out. Doesn't really check out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It does not check out. I don't really understand why it says that. Okay, so this is not great, but let me edit this register. I don't understand why it says that, for one thing, but I just want to make sure my math is okay. So I set it to B, which is 11 divided by 2, 5, okay. 14, 28, 2A. Oh yeah, no, this is, that's also wrong. Because I should have added the 2 over here. Let me see if to what extent that helps. Next. Run. It's going to be a lot of this for the next little bit. Well, yeah, that's also extremely wrong. It feels a little less wrong, but it's still extremely wrong. So replace with transfer. Hit run. Bam. Okay, so we are checking row C, which is row 13, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So not quite right still, but like close enough to being right. I don't know. I don't know why I found a collision in row C anyways. Like that doesn't make a whole lot of sense either. But because row C is this one, that's D and that's E. So I shouldn't have even detected a collision there, but no matter, I want to see what exactly we get for this. So now we're saying we're in row 8 by 8, which is like that's row 0, that's row 1, that's row 2, that's row 6, 8 by 8. But then we have to adjust it by 2 because of the column. God, what am I? I'm just rambling at this point. Is that right? I don't even think that's. What am I? Yeah, okay, I see. This is of course nonsense. For each 8 by 8 row, what I want to be I don't want to be multiplying by 8. I want to be multiplying by 32. Hence that swap and that shift logical. I just add a. That's the faster way to do it. There we go. So again, I feel like this isn't going to be quite right because there's still something off about things, but it should be righter. Just making baby steps towards correctness here. That's the idea. Let's hit run. Oh no, that didn't work. What? No, it kind of worked. This is a little better. It's a little better. I mean, now we're just getting craziness. But yeah, there's something a little off about this math here, but it definitely is like more in the right direction. I gotta take what I can get. Jeez. Anyways, I want to take a quick step back. I feel like there's something wrong with my row. Count for ball center. Right, that's the add 4. OAM Y offset mapster. Well, that all checks out extremely well to me. So why is it off? Actually, even that doesn't bother me as much as the fact that we're detecting collisions when I don't think we should be. Let me go over here. Check stage collide. And then check for collision. So we get an 8 by 8 pixel row. And then we're doing, this math is wrong, isn't it? Like we don't want to be multiplying by 8. We want to be multiplying by 16 because each row is 16 pixels tall. Let me see if that helps. That was the added benefit of being substantially shorter code-wise. Oh, yeah, there we go. Oh, almost. Something went wrong there, but yeah, something's a little wrong. But unfortunately, the more correct it gets, the harder it is to figure out what's going to go wrong. But a notable improvement there. Dang, I saw it starting to work. I was like, that's it, we did it, it's working. I've got an update available for TileAd. It's exciting. What's new? I probably am not going to use it, unfortunately. Sorry, I got distracted by looking at the TileEd release notes, which I can do later. So, brain. How do I figure out what's going wrong? Like it's working like 80% of the time, which is terrible because how do I isolate that 20%? Like I gotta figure out, like that worked. That worked. You know what I'm probably doing? I'm probably writing my results back to the wrong place in the stage map. Because I kept making this mistake of, yeah, that checks out. I kept making this mistake of multiplying by the wrong things for some reason. Because I'm an idiot and I haven't coded for 2 days and I'm rusty maybe. I think this should do it. I've got faith that this should do it. Looking good, looking real good. It's looking so good. Oh man, it's looking so good. It's totally working. That's it. It's working. Yes. Ugh. And that's just about as much as I wanted to stream for today. We're at an hour. Perfect. There we go. Collision detection. Did I do the laser collision detection as well while I was here? Init lasers, setup laser OEM, mark laser, fire laser. Yeah, I've got collision checking for lasers here, which I'm not going to commit. I want to test it though. Let me go to power up state. Modify code data R2. So now I have a laser. Uh-oh. Okay, so something's off here. So it's not quite ready for prime time just yet, the laser collision, unfortunately. But yeah, terrible things are happening now. We're just running garbage code. But everything else is good. Hi, Tom. Okay, so let's save that. Just everything except for the laser code apparently is working pretty well, I think. I'm not going to touch the laser code just yet. Refactor collision detection. One last time. Famous last words, knock on wood. This is a huge improvement. Look, I managed to delete 40 lines of code. I think that the collision detection code that I've got here is way saner than it was before. So I'm really happy with how this turned out. Yeah, that's going to be it for the day, unfortunately. Got things to do. But yeah, thank you for joining me. I will be back tomorrow. We're going to get the laser collision detection done finally. And then what do we have left? We've got to extend multi-ball and actually making the power-ups drop. And I don't know what I'll do next. We'll figure it out. Tomorrow, though, lasers. Anywho, that is all for today. Take care. Have a good one.